Chapter 1 is what is statistics, and we'll be learning a lot of terminology in Chapter 1. So the first is the definition, which is the study of how to collect, organize, analyze, and interpret numerical information from data. And throughout the whole semester, we'll be learning how to do each of these. Statistics is also used as a science of uncertainty and the technology of extracting information from data. Some good examples are gambling, sports, and of course gambling and sports a lot of times goes hand in hand, and then drug testing. There are two types of statistics that you need to be familiar with. One is called descriptive statistics, and you can think of the root word describe, and this would be the organizing, the picturing, and the summarizing the data. This includes collecting, organizing, and analyzing. We'll be covering this in the first part of the semester, so we'll get into that starting with Chapter 2. And then as the semester goes on, we'll get into what is called inferential statistics. And inferential statistics is when you use information from a sample to draw conclusions about the population. And here in a minute, we'll be looking at definitions for population and sample. And some types of inferential statistics are estimation, hypothesis testing, and regression. So if you're asked what are the two types of statistics, you need to know that there's descriptive and inferential. Some more terminology that you need to be familiar with in statistics is you need to know what makes up individuals. Individuals are the people or the objects included in the study. Here would be an example. If I were to do a study on 50 NOC students, these, of course, would be people, and the 50 that are included in the study are what we would deem our individuals. And then with the statistical study, you have what is also called the variable, and this is a characteristic of the individual or item that will be measured or observed. So if we were looking at 50 NOC students, you might be asking them, what is the number of credit hours that you are carrying this semester? That would be considered a variable. It is something that can be measured or observed. Now, in the category of variables, there are two types of variables, and you need to know the two types and be able to distinguish between the two. The first one is what we call quantitative, and it is a value or numerical measurement for which addition or averaging makes sense. And quantitative, you can think of the root word quantity. So it is a number, and that number is, you are able to add it and average it, and that makes sense. We will see there are some numbers that are not quantitative, and the reason they are not quantitative is because adding them or average them does not make sense. Now, above our example of number of credit hours would be an example of quantitative variable, because as you go further into college, you add your college credit hours together, so it makes sense to add them. If you wanted to figure out what is the average number of credit hours you carry per semester, so it makes sense to add an average credit hours. Therefore, this would be considered a quantitative variable. The other type of variable is qualitative. And this type of variable, it describes an individual or item by placing them into a category or group. A good example of this would be if you were asked, what is your major? So you would get responses like nursing, You might get English major, math major. That places each NOC student into a category or a group. And of course, you can't add or average a major. So that would be a good example of a qualitative variable. Now notice it says be careful. There are some numbers can be qualitative. For example, your zip code is a number that puts you in a group. My zip code is 73703. Well, it would not make sense to get a whole bunch of zip codes and add them together and average them. You can average zip codes, but then that number does not give you a number of value. It doesn't hold any relevance. So what this zip code does is it places me in a group. So when something gets mailed to me, then the post office knows that I am placed within this zip code group. All right, moving on. Some more terminology. And here we're going to talk about population and sample, which got referred to a little bit on the first page. Now I'm going to go back to my example of 50 NOC students. If we were doing a statistical study on 50 NOC students, and I want to relate that to then population data and sample data. So population data is when you use every individual or item of interest. This is not a population data because there are more than 50 NOC students. Now this was pulled from a population, so if we were looking at this statistical study, the implied population would be all or every NOC student. So the key with population is the word all or every. Now, anything we extract from the population as a numerical measurement is what we call a population parameter. You need to be familiar that parameter goes with population, and the easiest way to remember that is they both start with a P. So a population parameter is a numerical measurement that describes an aspect of a population. So if I took all NOC students and averaged their number of credit hours, that would be considered a population parameter. Now, what we will deal most often with is sample data. And sample data is when you use only some or a portion of the individual's or item of interest. So in our example, those 50 NOC students would be your sample. We did not, or in this particular example, it would be too timely to gather data from all NOC students, so we draw a sample of 50 and it makes it a more manageable number. Now, any numerical measurement that we calculate off of a sample is called a sample statistic. Just like population and parameter both start with the letter P, the easiest way to remember this is sample starts with an S and so does statistic. And it is a numerical measurement that describes an aspect of a sample. So if we ran the average number of credit hours for these 50 students, that number would be a statistic because we got the data from those 50. A parameter would have had to have gathered all the data from all of the students. So that is the difference. Now, what you're going to need to be able to do is to take an example such as this and answer these type of questions. So let's go through an example of what you might see. The Utah State Legislature wants to estimate the length of time it takes a resident of Utah to earn a bachelor's degree from a state college or university. A random sample of 265 was taken from recent in-state graduates. Okay, so the first thing that we want to do is identify the variable. So in essence, that is what is being measured? What is the question being asked? So if I go, I'm not sure, I read through that once, but I need to read it again. The Utah State Legislature wants to estimate the length of time it takes a resident of Utah to earn a bachelor's degree from a state college or university. So what they're gathering and what they are asking is basically the length of time it takes to earn a bachelor's degree. So the variable being measured is length of time it takes a resident of Utah to earn a bachelor's degree. And that's from a state college or university. So basically, length of time is what we are measuring here. So that's the question that they would ask a recent in-state graduate. How long did it take you to earn your bachelor's degree? So think about the types of responses you would get. You might get 3 years, 5 years, 7 years, or you might get months, whatever their type of response would be. So then think about what type of variable is that. So we're looking at, is it qualitative or is it quantitative? And since we're getting a numerical value, this would be quantitative. And I want to make sure, would it make sense to add or average those? And it absolutely would. So this would be a quantitative variable. Now, the next question tends to cause a little bit of difficulty for some students, and that is, what is the implied population? So the implied population is, what is the population in which they gathered their sample from? So if you want to go down and look at what is the sample first, you can. Because here it says a random sample of 265 was taken from recent in-state graduates. So that right there tells me that the sample is 265 in-state graduates. So notice, not out of state, in-state graduates, and this was in the state of Utah. So your population is, where did they draw these 265 from? Well, remember, population is all or every. So that would be all in-state graduates. And again, we're talking about the state of Utah. Would not make any sense to gather data or use someone in the state of Oklahoma, because that's not what they're studying. So it needs to be all in-state graduates, and then you need to know it's from Utah. And of course, also these graduates are college graduates, not high school, not kindergarten, and so forth. So that is how you pull that information out from an example. Okay, moving on. The next thing that we need to know, terminology-wise, is what is called the different levels of measurement. Now, when you're gathering data, that's the information that you're asking the population or the sample. What you are measuring can be placed at a particular level. There is what we call nominal, ordinal, interval, and ratio. Now, what you need to be able to do is to distinguish your data into one of these four. So nominal would be names, labels, categories. So here's some example. Credit card names. That would be like Visa, MasterCard. Gender, male, female. Then the second level is ordinal. Think of the root word order. It can be ordered, but differences are meaningless. Rankings such as good, better, best, or class rankings. So if you were filling out a survey that was comparing things and your responses could be good, better, or best, that would be ordinal. Class rankings would be, an example of that would be like when you graduated high school, you ranked first in your class, second in your class, and so forth. Those are rankings to where we know this person is ranked first, but we do not know the difference between the ranking of first and second if all we know is their ranking. Another example is those, if you've ever played in the band and you would get first chair, second chair, and third chair. So we know this person plays a particular instrument the best, but what we don't know is the difference between the first and the second chair. Was it a really close race and they're almost identical, but this one was just a little bit better? Or is this one really good and second and third aren't very good, but that's the only other people playing that instrument? So we don't know the complete differences, but we just know this is the best person in that particular instrument. All right, the next one is interval. And interval can be ordered, but the differences, and now the differences are meaningful. No true zero. This occurs with two types of data. One of those types is temperature. And what no true zero means is 0 degrees does not mean that there is no temperature. We know if it's 0 degrees outside, it's cold. Also, this is not where temperature begins. We know that you could have negative degrees. Also, time. So time and temperature, such as a date, such as the year you were born, or a time such as 6 o'clock. And the reason is because 0 AD does not mean that there is no time, and 0 on the clock does not mean no time exists. Make sure you don't confuse this with length of time. So we'll talk about that. No, I guess I don't have an example of that. So here's what I'm talking about on time. If you asked what time does class start and somebody said 9:30 a.m., that would be considered interval. And what this means is, don't confuse this with length of time. If you're asked how long did class last and your answer was 55 minutes, that becomes this last one we're getting ready to cover. So this one is interval, this one is not. So be careful of those two. So the last one is ratio, which can be placed in order. Differences as well as ratios are meaningful, and there is a true zero. So 55 minutes before class began, class had lasted 0 minutes. And then as class proceeded, you began to add minutes. So that's why that one is considered ratio. So these are also some other examples: height, length, waiting time, money. Now, what you would be asked to do in homework, quiz, or a test would be to distinguish what is called the highest level of measurement. Now, not all the time will the directions then tell you that means nominal, ordinal, interval, ratio. The directions may only say list the highest level of measurement. You need to know when it talks about highest level of measurement that it is asking for one of these four. So be careful of that. All right, so let's go through some examples. So let's say someone told me their favorite cereal was Captain Crunch. Great snack. All right, let's say I asked somebody what their academic major was, and they said business administration. And then I was gathering data, and I said, okay, how many earned college credits do you have? And let's say somebody told me they have 41. Instructor evaluation 1 to 5, 1 being the lowest, 5 being the highest. So let's say that they gave the instructor a 4. The year of your birth, say somebody told me 1983, and then a student ID, I'm just going to make one up. Okay, so here are some examples. If you were gathering data, these are some possible responses you would get. So then what I would ask you is, what is the highest level of measurement? So are each of these nominal, ordinal, interval, or ratio? Well, Captain Crunch would be an example of nominal. It places them in a particular category. Your academic major, this would also be nominal. It places you in a category. Earned college credits. Okay, when I look at this, I go, okay, it is a number. And so I'm going, okay, it will most likely be interval or ratio. So then I say, does 0 have significance? So before I started college, I had 0 college credits. So there is a true 0. So this would be ratio. Instructor evaluation, 1 to 5. So it is a number. And it can be placed in order, but between a ranking of 4 and 5, I don't know how much difference is between those two. So this would be an example of ordinal. You place it in order, but the differences are unknown. The year you were born, so this would be time such as a date, so this would be interval. And then one that you need to be careful of is an example such as this, a student ID. It is a number. You can place it in order, but does that order have significance? Meaning, is the person 214001531, if I place them in order, that would be right above this. Does that mean that student is a better student? And the answer to that would be, we don't know. Just because they have that number doesn't mean they're a better student. So there is no significance to the order. What this does is it places to a particular person. So this would actually be nominal. So you need to be careful with that. So if we went back to qualitative or quantitative, those are your two different types of variables. This one would be qualitative. This one would be, whoops, I'll move that down, sorry. Second one would be qualitative. Earned college credits would be quantitative. And then instructor evaluation, so with variable, you go, okay, it is a number and there is significance to that number, so this would be quantitative. The year that you were born, there is particular significance to the order, and adding them does not make sense. You could maybe average and say, okay, the average year that someone was born, so quantitative, and then this would be an example of qualitative. All right, that completes chapter 1.1.